Lawrence Algebra, Mr. Lawrence here with your flipped lesson. Today is Monday, May 7th, and you realize there's only 3 Mondays left in the school year. I mean, you're watching this video today, you want to count this one, but you already went to school today. There's only 3 more days you have to show up on a Monday, 3 more weeks that you have to show up on a Monday. Not 3 weeks, but 3 weeks that you have to show up on a Monday. All right, because we got a Memorial Day in there. The school year is winding down quick, and we got to get this material done because we got a final coming up, but that's all right. Deep breaths. You guys are working hard, most of you. I'm very proud of many of you. Some of you are getting the best scores you've ever gotten. You're working hard at maybe the hardest time of the year. Very proud of you. All right, today we're going to learn how to graph rational equations. And let me go ahead and minimize this. And am I holding the red marker? No, good. Okay, the first thing I'm going to do when I go to do my graph is I'm going to notice my restriction. My restriction here, what is going on? My restriction here is that x cannot equal -1, right? Well, what does that mean? That means that on my graph, I'm going to get an asymptote where x is -1. And so I'm going to go to x is -1. We should all know that that is a vertical line by now. All right? And there's going to be an asymptote there. That graph will not cross x equals -1. It might appear on both sides, but it won't cross to get from one side to the other. Okay, and there's actually going to be another asymptote, but I'm not going to tell you what that is. Courtney Ozanich knows, but the rest of you, you're going to have to watch and see. So I'm going to make a t-table over here, and I'm going to stick only with positives. And you're not going to have to do this with all the graphs, but I'm going to make a few extra points because it's the first time we're doing it. And I'm going to say put in some large numbers like 10, and then medium, and then 2, and then 1, and then I might as well put 0 in. 0 is okay. And then I'm going to put, let me see here. Yeah, I like this. I'm going to put -1/2, and I'm going to put -1/5, and put -1/10. And I just chose to get really close to the asymptote. So the y-axis is where, you know, x is 0, right? And then I went closer. I went to -1/2, and oh, silly me. I shouldn't go -1/10. I should go -1/2, and then like maybe a -3/4, and then like maybe a negative. I'm trying to get as close to, you know, -1 as possible. So maybe like -9/10. That's pretty close to -1. And watch what's going to happen when I do this. Okay, so I'm going to do my math here, and you know, of course, I'm plugging into this equation right here, 1 over x plus 1. Well, when I get x is 10, I get 1 over 11. And so let me see here. When x is 10, I get 1/11, which is going to be a little point right above the x-axis. And if I put 5 in there, I'm going to get 1/6. Right? So 1, 2, 3, 4, 5, 6. Oh, 5, and then 1/6 is, you know, right about there maybe. Okay, and I put 2 in, I'm going to get 1/3. And so at 2, I'm going to be 1/3 of the way up. And then at 1, I'm going to get 1/2. Right? Okay. And then at 0, I'm going to get 1. Oops. I'm going to get 1/2. At 0, I'm going to get 1. Okay. And then when I go to -1/2, right? -1/2 is the next one. I'm going to get 1 over -1/2 plus 1. Well, -1/2 plus 1 is 1/2. 1 over 1/2 is 2. So at -1/2, I'm going to get 2 out. And you can see this thing start to climb. Okay, and then when I put in, say, -3/4, right here, I'm going to get out a +1/4. 1 over 1/4 is 4. So I'm going to be right about there, maybe. And then when I put in, what's the last one? What was that? I was going to get 4. And then we put in -9/10, which is pretty darn close to -1. I'm going to get 1/10 out. 1 divided by 1/10 is 10. And so it's going to be right about there. Now, the first part of this graph, it's pretty obvious, is going to do something like this, okay? Now, you may not be sure what's going to happen here. Some of you might be guessing that there's an asymptote along the x-axis, and you're right. Let me ask you this. What's the value of y on the x-axis? I mean, if I'm here, that's the point, what, 6, 0, I think, right? This is the point 2, 0. These points are not a part of my graph. I'm just making a point. This is negative 4, 0. Y is 0 on the x-axis, right? How do you get 0 as a fraction? Don't you need a numerator of 0? Like, for example, 0/5 equals 0. 0 over 700 equals 0, right? You see this fraction right here, this equation? The numerator is 1. Is there any value of x that you can put in that will change that 1 into a 0? No, there's not. So yes, those of you suspecting that there might be an asymptote here along the x-axis, you are absolutely correct. There is an asymptote right along the x-axis. I'll move that up a little bit. All right, now there shouldn't be this little dip here. This is human error. This little dip here is human error. All right, now I need to find out what happens on the other side of my asymptote, meaning when x is smaller than -1. Let me get rid of these green points in here. They're messing things up. And so I'm going to continue with my t-table. I can get rid of these. And I think with some of these I can just change them negative. Like I can plug in -10, -5, -2. I can't plug in -1. That's where my asymptote is. So I'll erase those. But I'll start to get closer to -1 from the other side. So that would be like, what, -1.5, right? -1 1/4. And we'll do one more. -1 1/10. Okay? All right, so I'm going to plug these into the equation and see what I get out. Well, I get 1 over -10 plus 1 would be 1 over -9, so -1/9. So when I'm at -10, I get -1/9. And that is going to be, ooh, looks like I saved it in the wrong place, but that's okay. It's going to be way over here somewhere. All right. When I put -5 in, I'm going to get 1 over -4. So in other words, -1/4. So 2, 3, 4, 5, about a quarter of the way, and that looks like it's off a little bit, but that's okay there. And okay, so let me see, where am I at? -2, I think, is going to give me an answer of -1, right? Check my math really quick. -2 plus 1, -1. So it's going to be -1. So at -2, I'm going to be at -1. -1.5. Well, my denominator, I'm going to get a -0.5. 1 over -1/2 will be -2. So as I start to get closer, it's going to climb in the negative direction. And I'll do -1 1/4 plus 1 will be -1/4. So that'll be -4. Right about there, I'd say. And then -1/10 will end up being -10, like that. So this part of the graph is going to do something like this. Something like that. Okay, it's going to be hard to get it exactly perfect. I think I did a better job with that one than I did the first. Now, if you wanted to verify this, you guys are so lucky. You could go on to this website here, where am I at? Cool Math. And here I have a graphing calculator, and I'm going to type in my equation. What was it? 1 divided by, and I think it was x plus 1. Oop, I better put that in a quantity. Let me see here. How do I backspace? I don't know. All right, I'll just retype it. How do I hit clear? Is this it? Good. All right, hold on. Let me put that in a quantity so that the calculator doesn't misunderstand what I'm doing. And then now I'm going to evaluate this. And sure enough, I got something like that. It looks like my y minimum, y max aren't going very far from a problem I was doing Courtney earlier. So let me change that to, oops, 10 and 10 there, negative 10 and positive 10. And there we go. And you notice this area right here. This is the asymptote. The graph doesn't actually show it, but you can see how the graph is breaking. And then the other asymptote is the x-axis, right? Because it's hugging it right there. Okay, very cool website. Very cool website. Check it out. It's www.coolmath.com, and then you can do the graphing calculator. All right, so let's see here. Let's look at one more example. What do I have here? X minus 3. Yeah, we can do that one. That one should be pretty simple. And then we'll slow this down a little bit. I was going to do more examples with you, but I don't want to pull you away too much. So we're going to go 1, 2, 3. What did I just do there? I put an asymptote in, but why? Well, my restriction is that x cannot equal the number 3, right? So I have an asymptote where x equals 3. There's my asymptote. All right. Tell you what, this isn't going to change the problem. I'm going to add 2 to this problem and see what happens to it. Okay, now I'm going to make my t-table x and y. And I'm going to determine what happens when I get close to the asymptote on both sides and what happens when I get far away. So 3 is the magic number in this case. So I'll tell you what, I will try something really close to 3 on the positive side, so 3 and 1/10. And then I will try 4, and then I will try 10. And I'll bet you I can get a pretty good idea of what's going to happen with that. All right. There is going to be another asymptote, a horizontal one. It probably won't be 0 in this case, but it will turn out. So let's see if we can figure this out. All right, let's put 3 and 1/10 then in our denominator. So I'm going to get 1 over 1/10, which is 10, plus 2 is 12. Okay, so when I'm really close here, I'm going to get this point 11, 12. Say like right there. Okay, and then I'm going to infinitely clone that. All right, when I put 4 in, I get 4 minus 3 is 1. I get 1 over 1 plus 2. That'll end up being 3. So when I get 4, I drop all the way down to 1, 2, 3. Okay. Now, when I plug in, say 10, I get 1/7, right? 10 minus 3 is 7. 1/7 plus 2, so I get 2 and 1/7. Okay. And that will come, what number did I put in 10? So we get 1, 2, and 1/7 right about there. Are you guessing you know the horizontal asymptote? I think you do. Tell you what, let's put in a ridiculous number, like a really large number, like say 1003. Well, I'm going to get 1 over 1003 minus 3 plus 2. That's going to be the same as 1 over 1000 plus 2, which is 2 and 1,000th, right? Which is 2.001. Very, very tiny number. Do you think you know the asymptote now? Yeah, the horizontal asymptote is going to end up being 2. This thing will not cross the line of y equals 2. Do you think it's a coincidence that we had a plus 2 on the end of the equation? I think not. All right, very good. Okay, so the graph on this side, on the positive side of the vertical asymptote, is going to do something like this. Okay? All right. Now, let's go over to the other side, and, I'll remake my t-table. You guys can just add on. Don't waste time erasing. And I'm going to do x and then y. Okay. I can put a negative 10 in, I guess, if I want to. All right. I'm going to put, say, a 0 in. I'm going to put a 1 and a 2. The asymptote occurs at 3, so I'll even do like a 2 3/4. Okay. When I put negative 10 in, I get 1 over negative 13, right? This will turn out to be 1 over negative 13, which is negative 1/13. Negative 1/13 plus 2. Well, if I take 1/13 away from 2, I'm going to be left with 1 and 12/13. So, when x is negative 10, way out here, I'm going to get a 1 and 12/13, which is pretty darn close to 2, right? Okay, so that was what, 1 and 12/13. Okay, when I put 0 in, I get negative 1/3 plus 2. Well, if I take away a third from 2, I'm going to be left with 1 and 2/3. Okay, so at 0, I'm going to be at 1 and 2/3. Maybe it's right about there. All right, when I put 1 in, I'm going to get negative 1/2 plus 2. That's going to be 1.5. So 1.5. You can see it's going to start bending real soon here. All right, so that's 1.5. When I plug 2 in, I'm going to get negative 1. Negative 1 plus 2 is positive 1. Okay, there's the curve starting. And then when I go 2 3/4, if I have 2 3/4 minus 3, that's going to be minus 1/4. 1 over negative 1/4 is negative 4. Negative 4 plus 2 should be negative 2. Something like that. And you can see that the graph is going to end up doing something. It's going to really hug that guy, start to break away, and then it's going to curve and then climb way down. And it's going to really hug over there too. Oops, I forgot my arrowhead on the negative end there. Okay, let's take a look on our cool math, and the equation was what? 1 over x minus 3 plus 2. And so let's clear this out. And let's see if I can just do this. I'm going to add 2. And that should do it for me. I should be able to get the picture I want. It should not misinterpret what I'm telling it. And there you go. That looks pretty much like the same thing. There's my asymptote at x is 3. And that's it. All right. So that's your lesson for tonight. Mr. Lawrence signing off. We'll get some practice with this tomorrow. Good night, everybody.